So this first block of controls is how we would set imaging parameters for a single live configuration channel. So we have, or we'll start with here, a pull down in the middle of each of the channels that we have available. So we have the 5 fluorescent channels that are configured on the system, as well as a bright field LED. I can start live to take a look at 488 here, fluorescence. So I know that I'm live because I can see intensity fluctuations as new frames are captured. I can control the exposure time of the camera with this dialog box. So perhaps I'll change this to 200 milliseconds instead of 100 milliseconds. So you can see the image gets about twice as bright. If I change this back to 100, I can also change the analog gain on the camera. So if I change that to 20, I should get a very large increase in the brightness of the intensity of the pixels that I'm collecting. So I'll change that back to 10. And then finally, I can change the actual the excitation source brightness. So how much light are we actually delivering to the sample from, in this case, the 488 LED module by toggling this large input bar, or I can dial in discrete values using this input box. So maybe I'll pick 50%. Finally here we can turn on and off auto level. So you'll notice you have some fluctuation here. So what's going on is as the new frames are pulled from the camera, an automatic lookup table is being applied to try to keep the intensity in view or in the visible range of the monitor. But I can turn that off, and turning that off while you're setting parameters oftentimes makes it a little bit easier to see what the effect of that changed parameter is. So basically I'm just keeping that lookup table constant, and I can see a little bit more easily and compare between different parameters as I set them. We can also here under live change how quickly we are capturing frames in live. So right now I'm capturing frames at 10 frames per second. I could say change that to 1 and start live. So now I'm only going to capture a new frame every second or so. In the case that I have a very fragile or photolibel sample, we can keep those from photo bleaching. Additional control we have here is our trigger mode. So we have 3 modes here. We have software, hardware, and continuous acquisition. So software is sending software commands to both the illumination source and to the camera. Hardware trigger is sending the software command to the microcontroller unit, and then coordination happens there. Can be a little bit more precise, a little bit faster, really depends on your imaging needs. And continuous acquisition, for now, we may kind of skip and put in its own module. So maybe I'll pick just software trigger for now. So my task then is for each of these channels that I'd like to use in an experiment. I'm going to go through, I'm going to set these individual exposure time, illumination, and analog gain channel parameters such that they give me the image that I'm looking for, and then I can input them into, in this case, the well plate multi-point acquisition. Notice that as I go between channels, so say I'll change illumination to 488 on 48, and then I'll change illumination to 561. When I go back to 488, those settings are remembered per channel. So those are constantly being updated. There's no need to set save or anything like that. They're automatically updated into the same parameters that are taken for the experiments. If I'm very happy or I would like to consistently apply the same imaging parameters, I can actually save these as a configuration profile. We have default, but we can save these as anything you want and pull them back up so that you can have per experiment or per user configuration profiles, which will pull in all the acquisition parameters. Last thing, we also have the ability to do Z offsets per channel. So if I click this on, I now have an additional set of controls that essentially allows me to set, say, a single focal plane where I'm actually going to say focus on DAPI if I'm using either contrast-based autofocus or laser-based autofocus. And then I can offset the other individual channels by 2 or 3 microns or as many as are required in order to capture the features of interest, assuming that they're not at the same Z focal plane. So that's again C show Z offset controls. So that's how we set the parameters for each individual channel that again will feed into those channels here when we generate experiments.